Dear viewers, in the video, let us solve this problem. That is, we are going to show that the continuous image of a path connected space is path connected. So let me recall what we mean by path connected. So definition. So recall பண்ணிக்கிறேன். So recall. Okay. So what is that? Let capital X be a topological space. Be a topological space. Topological space. Okay, and x comma y belongs to capital X. Okay, a, by a path a path connecting connecting x and y is a continuous function continuous function. Okay, it is a continuous function f from closed interval a comma b to okay x, where for some closed interval a comma b subset of R. Okay, this is R. And note that a path connecting x and y is a continuous function f from closed interval a comma b to x such that such that the condition is this f of a which is equal to x and f of b which is equal to y. Okay, that is a path between path starting from x to y that is given by a continuous function. Okay, a topological space x is said to be x is said to be said to be path connected path connected if any two points any two points x comma y belongs to capital X is connected by any 2 points can be connected by a path. Any 2 points can be connected by a path. Okay, what do you mean by path? That is, it is a continuous function from closed interval a comma b to x such that f of a which is equal to x and f of b which is equal to y. Okay, so now we'll prove the statement of this problem. Okay, we are going to show that a continuous image of a path connected space is path connected. Okay, so given capital X is a path connected space. Capital X is a path connected space. Connected space. Okay, fine. So now we are going to have a let capital Y be a topological space and I define a function. Let me define h is a function from x to y be a continuous function. Continuous function. Now we claim this h of capital X is path connected. So this is the theorem we are going to prove today. Okay. Okay. So that means any 2 points in h of x can be connected by a path in capital Y. So let me take a 2 point. Let let us take let now I'll take a 2 point here. That is, shall I take? I'll take that y1. Okay, y1, comma y2 belongs to. I'll make it way. This is h of x. I'll make let y1 and y2 belongs to h of x. Then there are x1 comma x2 belongs to capital X such that I'm having, that is, y1 which is equal to f of x1 and and y2 which is equal to f of x2. So these are the 2 points because it is, sorry, not f, it is h of x. I'll make it is h of x1 and it is h of x1 and it is my h of x2. Okay. Okay. Now since since x1 comma x2 are elements of capital X and capital X is path connected path connected. Okay, so we shall see uh, there is there is a continuous function continuous function. I call it v f. It is a function from some closed interval a comma b to x such that what we will have, that is f of capital A, f of A which is equal to x1 and f of B which is equal to x2, x1 and x2 we have. Okay. Now note that this is a diagram I am making. That is, suppose if you are having this, it is a function from capital X to Y. It is a function. What is this? This is h is a function. Okay, and we are having, this is closed interval a comma b to capital X, which is a function that we call it b f. Okay, now let us consider the composite map. Okay, so consider the composition function. Consider the composite map, the composite function. What is that function from here to here? Okay, we are going to here to here. That is from closed interval a comma b to y via f and h. Okay, so it is a function from, this is called h composition f. It is a function from closed interval a comma b to, it will come to x, and from x it will come to y. Okay, so it is f operator and it is h function. Okay, so clearly since h and f are continuous, continuous. Okay, this new function I call it b, this is called it b g. Okay, g is continuous. Okay. Okay, and and that is g is a function from where to where? It is a function from closed interval a comma b to, I'm having it is to be y. So how we are defined? That is g of a which is equal to h of f of a. What is it? Which is equal to h of, what is f of a? F of a which is equal to x1. So we will have this is x1. And what is h of x1? H of x1 which is equal to y1. So we are having it is to be y1. And what is g of b? G of b which is equal to h of f of b, which is equal to h of x2, which is equal to, it is given that it is y2. Okay, so that is that is g is a path. G is a path connecting connecting y1 and y2, y1 comma y2. So since y1 y2 belongs to f of sorry, h of x, which is arbitrary, we have that h of x is path connected. Okay, that is that is any 2 points, any 2 points in h of x can be connected by a path, can be connected connected by a path, by a path. So this implies that h of x, which is connected x path. Okay, hence the result. So we use this result, that is continuous image of a path connected space is path connected. We use this result to prove that another interesting problem, that is, it is a problem. We are going to show that problem. So what it is, Abdina, that is, uh, let let's yes, I call it to be the definition of, we always call it to be, it is Sn minus 1, which is called to be, this is equal to set of all the vector. Okay, it is a vector in Rn such that norm of x, which is equal to 1. It is called to be a unit sphere, where what is the norm of x? Norm of x, which is equal to this is summation I equal to 1 to n, okay, modulus of xi, the whole square, the whole power 1 by 2, where for every x vector which is equal to x1, x2, xn. Okay, so now we claim that, then then this s to the power n minus 1, this is the called to be a unit sphere in, it is called to be unit sphere in Rn. It is called to be unit sphere in Rn. So Sn is going to be is connected. So this is the theorem problem we are going to show. And note that this fellow need not be a convex set. Okay. So this is the main thing. And we already seen that every convex sets are connected. But this fellow is not a remark. Note note that closed unit ball Bn, okay, so which is equal to set of all x belongs to Rn such that norm of x, which is less than or equal to 1, it is convex, and hence it is connected. We have already seen that every convex sets are connected. But in this case, Sn is not convex. Note that this Sn minus 1, that is equal to set of all x vector in Rn, okay, such that norm of x, which is equal to 1, okay, is not convex. So we cannot use this. So now what we are going to show is, we already know that, we already know, we know that, we know that, know that this Rn set minus singleton 0 is connected. So this we have already seen. This Rn set minus singleton 0 is connected, and now we are going to give define. Of course, we have shown a very strong condition that It is path connected we have shown. This Rn minus 1 is path connected. Rn set minus singleton 0 is path connected. Connected. And hence it is connected. We have already seen that every path connected spaces are connected. So here Rn set minus singleton 0 is connected. How we have proved? Let me recall this. So how it is, how we have proved it? Just recall that. Let x comma y belongs to Rn set minus singleton 0. Rn set minus singleton 0. Consider the straight line. Consider the straight line. Straight line joining x and y, x vector and y vector, and x and y. Okay. If 0 is not in the straight line, in that straight line, then it is a path. It is a path connecting connecting x and y in Rn set minus singleton 0. Rn set minus singleton 0. Suppose if you are having, that means, for example, if you are considering a R2, so this is the point you have excluded. This is R2 set minus singleton 0. R2 set minus singleton 0. Suppose if you are taking 2 points here, suppose this is my x and this is my y, then this is a straight line connecting x and y, where this x 0 is not in this line. Okay. Suppose if 0 is in this straight line, if 0 vector is in the straight line joining x and y. Okay. Then choose any point is it not in the straight line, in that straight line. Okay. And consider the path connecting x and z, and then z and y. Okay. See, I am just giving the idea. We have already discussed it in very detail. Okay. So what it is, I'll make it again. So suppose if you are having, this is point. Suppose this is your x. And this is your y. Okay. And note that this point is excluded. So any straight line, if 0 is in this straight line, then you just choose an z. Suppose z which is not in the straight line. Then we consider a straight line connecting x and y, x and z, and then z and y. So this will be the path connecting, starting from x and ending with y in, this is the thing, in Rn set minus singleton 0. Rn set minus singleton 0. Okay. So this implies that Rn set minus singleton 0 is path connected. Okay. Now we claim that this fellow. Okay. Now we claim that is Sn minus 1, that is equal to set of all x belongs to Rn such that norm of x which is equal to 1 is, first we claim that it is path connected. Okay, it is path connected. Okay, so that means I'm going to find a continuous function from Rn minus singleton 0 to Sn minus 1, so that the range of this fellow is nothing but Sn minus 1. So how we are going to define is define 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 G is a function from Rn set minus singleton 0 to Rn. In fact, we can give it to be in not in Rn. We'll give that this is Sn minus 1 by by g of any vector x vector, which is going to be this is x vector divided by norm of x vector. Norm of x vector. Okay. So clearly, 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 this g of x belongs to Sn minus 1 for every x belongs to for every x belongs to Rn set minus singleton 0. Okay. So clearly, and and G is continuous. G is continuous. Continuous. How it is continuous? Because we know that the norm function is continuous. Okay, and norm function is not going to be 0. There, which is not going to be 0. Therefore, 1 divided by norm x is continuous function. It is an identity function. So, quotient of two continuous function is always be continuous. Therefore, G is a continuous function. And note that note that what I'm having, this G of Rn set minus singleton 0, which is going to be this Sn minus 1. Okay, that means this implies that since this fellow is path connected, since Rn set minus singleton 0 is path connected, connected, we have by above discussion, above problem discussion, we have this Sn minus 1 is path connected. Path connected. And hence, we know that every path connected space are connected, and hence, hence, Sn minus 1 is connected. Okay. Hence, that's it. Okay, I'll stop here. Thank you.